Hello! Do you know that for the purpose of calculation, you can choose to use a number that is close to the real number? And when we do this, we use a curly equal sign. When you do that, you can say an approximation has been done. My name is Kingsley Linus. Welcome to another interesting mathematics lesson. In today's lesson, we'll be learning about approximation. By the end of this lesson, you should be able to approximate numbers to any given degree of accuracy. And secondly, you should be able to solve quantitative reasoning problems related to approximation of numbers. So, approximation is simply the act of approximating. And what do we do when we approximate? We simply take a number that is very close but not exactly the same, as long as it can represent the original number. In approximating, we actually round off. And round off involves rounding up or rounding down. We'll be learning more about what rounding off is in this lesson. For the purpose of emphasis, approximation is a process carried out on numbers in order to obtain a number that is close enough to the right answer. Sometimes when we do calculations, we need to use rough estimates. Approximation helps us achieve that. It is necessary to know that when we do approximations, we don't necessarily need the accurate number, but we just need to have an idea of what the size of the number we use is. You can see the symbol for approximation. In approximating numbers, what we basically do is rounding off. And rounding off entails either rounding up or rounding down. We'll be learning about that shortly. Basically, when we round off numbers, we actually take a simpler version of that number for the purpose of calculation. The result of rounding off numbers is less accurate but easier to use because it gives us a good idea about an exact amount, value or measure of items, objects or quantities. And secondly, it can make numbers a lot easier to do calculations with. For example, if you do a calculation on a calculator and then you have a situation where you have so many digits after the decimal point, you realize that it will be difficult to do calculations with that large number. So what do? You simply approximate. To round off numbers has a rule. And the rule is simple. When you're about to round off a number, possibly to a degree of accuracy, you look for a number we refer to as the target. The next number after the target, if it's between 1 and 4, you round down. And if it's between 5 and 9, you round up. Now, what we mean by a target is the number that has the place value for which you are expected to do that calculation. So, just to explain that clearly, you can see we have the number 183 and we are expected to approximate it to the nearest 10. Now, just to re-emphasize what I've just said, for example, we have the number 183 and we are expected to approximate it to the nearest 10. Now, our target is that number that gives us the degree of accuracy to which we want to carry out this approximation. In this case, 8 falls under the 10th place value. Now, it becomes our target. And therefore, we look at the next number to the right of our target, which is the number 3. Now, from our rule, when we have numbers from 1 to 4, we round down, meaning that we can then approximate this number to the nearest 10 as 180. And in another situation where we need to approximate the same 183 to the nearest 100, the number 1 is our target and 8 is the number that determines what we will do, either rounding up or rounding down. Now in this case, because we have 8, we'll round up. And that means we'll add a 1 to our existing one, and that gives us 200. Now, having seen what rounding off is about, you must also know that rounding off uses the idea of closer or nearer to. Let's find out what this means. We have an activity. The instruction says, from the options, choose which number is closer to the given number.
Editor, please help me put comma after options.
Okay, that's true. Okay, thank you. First, we have 22. Now, is 22 closer to 20 or 30? You realize that 22 is closer to 20. So, it's easier for us to use 20 to represent 22. Secondly, 900. Is 900 closer to 100 or 1000? You see, 900 is closer to 1000. In the third situation, we have 0.35. 0.35, is it closer to 0 or 1? It is actually closer to 0. And lastly, see if you can do this. We have 1683. Is it closer to 1600 or 1700? I guess your answer is 1700. I'm sure that was quite easy, wasn't it? This is basically what rounding off is about. If you have to round off numbers, you would always be instructed on what degree of accuracy to round off those numbers to. For example, to the nearest 10, to the nearest tenths, to the nearest 100, 1000, naira, whole number, decimal places, and even significant figures. We are going to see some examples to better understand what I've just said. We have an example that says, round off 76.354 to the nearest tenths, hundredths, whole number, and tenths. First, to the nearest tenths. It is very important for you to understand your place value when carrying out approximations. Now you can see I've neatly set out my numbers with their place values written above them. I would advise you do a similar arrangement when you're solving questions like this. Now, for the first part of the example, we are expected to round off to the nearest tenths. Here is our target. I believe you know what target means. The next number to the right of our target is 5. And when we have a 5, we actually round up, meaning that we are going to add a 1 to the number 3. So that results in 76.4 as our solution to that problem. Secondly, we're expected to round off to the nearest hundredths. Here is our target for this situation, and the number to the right is 4. For the number 4, we round down. So we would have 76.35. Now take note, when you are rounding down, you don't need to do anything special. All you need to do is to cut off the numbers after the targets. For the third part of this example, we are expected to round off to the nearest whole number. Now, don't let the term here confuse you. Whole number is the same as units. So, the number 6 is our target, and the number to the right is 3. So we round down, and then our result becomes 76. And lastly, we are expected to round off to the nearest tens. 7 is our target, and 6 is the number to the right, so we will round up. We'll add a 1 to 7, and that gives us 80. I hope those examples were clear enough. Let's see some other example. Approximate 265.3554 naira to the nearest 2 significant figure, 3 decimal place, and nearest naira. First, for 2 significant figures, just like we had in the previous example, it is also important to set out your numbers in this manner, just so that you don't make mistakes. Now, 6 here is our target because we are expected to round off or approximate to 2 significant figure, and 6 happens to be under our second significant figure. So 6 is our target and the number to the right is 5. So we will round up. Therefore, our result becomes 270 naira. For the second part of this example, we are expected to round off or approximate to 3 decimal places. Now, for 3 decimal place, it means we are going to start counting the digits after the decimal point. That's what we mean by decimal place. Now, having had that understanding, 5 here is our target. And the number to the right of 5 is 4. So we round down. Recall that rounding down simply means we are cutting off the digits after our target number. That gives us a result 265.355 naira. And lastly, we are expected to approximate to the nearest naira. You realize that the digits after the decimal points are in fractions of naira, so they are in kobos. Now, to the nearest naira means our target is going to be the number 5. The number to the right of 5 is 3. As a result, we have to round down. So we cut off these numbers and then our result becomes 265 naira. Still talking about rounding off numbers to a degree of accuracy, let's see some word problems. The first example says there are 2 sevens in the amount 19,711,170 naira. Write down the amount of money that each 7 represents. Your place value again, still very, very important. You can see that we have the first 7 here and the second 7 here. The first 7 falls under hundreds of thousands. So the first 7 represents 700,000 naira. And the second 7 falls under the tens place value. That means 70 naira. Then to the second example, it says the actual age of a hospital patient is 39 years, 8 months, 29 days. A doctor asks the patient's age. What will be the reply? If you look at this question carefully, you'll realize there's no point explaining to details the number of days and months and all of that. So we can simply say that patient is 40 years old. And by this, I'm sure you know we rounded up. I'm sure you know it's time to do it yourself. Do well to pause this video and try out these questions. I'm sure you are done. The correct answers to these questions are 120, 124.3, 29, and 30. If these were your answers, you are correct. Now, we have quantitative reasoning problems that have to do with approximation. Let's find out what happens here. For our first sample, our original number is this number here. Now, the situation we have here is that from the top here, we have a situation where we approximated this number to 2 significant figures, meaning that 1 is our target and then we approximate. So that is what we have here. And here we have approximated to 3 significant figures and 4 significant figures. In the second sample, having this as our original number, from the bottom we have 1 significant figure, 2 significant figures, and 3 significant figures. Now, for our third sample, we have to figure out what the answer to this place is. Now, this is our original number as usual. You realize that here we have the number approximated to 1 decimal place. And when you look at this number, you discover that the same number has been approximated to 3 decimal places. It means our answer here is going to be to approximate the number to 2 decimal places, and that will be 86.51. And for the last sample, as usual, this is our original number. If you look at this, you realize that this number has been approximated to 3 significant figures, while this to 2 significant figures. It means our answer here is going to be approximated to 1 significant figure, and that would be 9,000. I'm sure those samples were easy. Again, it's time to do it yourself. Pause the video and try out these questions. I'm sure you are done. The correct answers are 3, 1, 0, 7. Now you can have either 1, 2, 3, or 4 as the last digit. But for me, I'll choose 2 as the original number that translates into all of these. Here, the answer to this question is 39.74. And for our third exercise, the answer is simply 43.5. And lastly, we have 0.059. If these were your answers, you are correct. Having learnt this much, we have come to the end of this lesson. But before you go, let us look at all we've learnt in a summary. First, we learned that an approximation is anything that is similar, very close to something, or close enough to be used, but not exactly equal or the same. We also learned that the symbol for approximation is a Cauley equal sign. Thirdly, we learned that we approximate numbers by rounding off, and it involves rounding up or rounding down. Moving on, we learned that rounding off a number means making a less precise version of it. And lastly, we learned that the rule of rounding off is this. If the digit to the right of the target is less than 5, we leave the target digit the same. But if it is 5 or more, we increase the target digit by 1. It's test time. Question 1 says, a school has 34 classes. One of each class has 30 students. Approximate to 1 significant figure the number of students in the school. Option A, 1,030 students. Option B, 1,020 students. Option C, 1,000 students. Or option D, 1,100 students. The correct answer is option C, 1,000 students. Question 2 says, divide 2.647 by 0.9 and give the answer correct to 2 decimal place. A, 2.91. B, 2.41. C, 3.00. Or D, 2.94. The correct answer is option D, 2.94. Here is where we come to the end of this lesson. Thank you for your time. Till we see you again in another mathematics lesson. Bye-bye.